Hello, algebra students. Today we are going to be actually starting to graph parabolas. So would you please take out your graphing parabolas worksheet? We're going to be doing some of the problems right from your practice problems, your homework together so that you can kind of see how this is going to work. So here's number one from your worksheet. If you remember from our previous lesson, when we find the axis of symmetry, the equation for that is x equals the opposite of b over 2a. Once we know that axis of symmetry, then we can use that x value to also find the y value for the vertex, and then we'll find the x and the y intercepts from the graph. So in number one, I want you to start every single problem by listing what the A is, what the B is, and what the C is. So, by the way, if you're not in the habit of actually doing these problems along with the video while you're watching it, this one, please do these problems right with me. We'll get these taken care of, and then you'll have some decent examples to look at later when you're doing some more of these. So the A is the number that's in front of the x squared. I don't see a number there, which means it's really a 1. The b is the number in front of the x. Don't forget the negative on that one. That's a -6. The c, that's going to be 0 because I don't have a number here. I could write +0 if I wanted to. I could put that 1 in there. I could even do a keep, change, but that c is going to be 0. Now that I have that, let me erase all this mess on the equation so it's not so hard to follow. I'm going to find my axis of symmetry. So x equals the opposite of my b is a -6 over 2 times 1. When I do that, I'm going to get the opposite of -6 is 6 over 2 gives me 3. So my axis of symmetry is 3. And I could, right now on my graph, sketch that axis of symmetry. Oh, my alignment's a little bit off. I'm going to try to keep that as close as I can. Now that I know the x part of my vertex, I want to find the y part. Remember that vertex is going to be on the axis of symmetry. So the x part I already know is going to be 3. I want to put that 3 in for the x in my equation. Let me switch colors now. So using the equation I have there, I'm going to say y equals, the x was 3, so 3 squared minus 6 times 3. Well, 3 squared is 9. 6 times 3 is 18. And 9 minus 18 is going to be -9. So my vertex, keep that all one color there, is going to be at 3, -9. So I could plot that point right now. I hope I counted that right. Let me just double check here. Yeah. So 3, -9 is my point. To be able to graph the rest of this, we have to make a table of values. I'm not giving you a table of values. You're going to have to make your own. And my writing, by the way, with these kind of markers, it's going to be really big. On paper, you should be able to fit all of this, but I can't when I'm doing this here. So if you need to use other paper, if you write bigger also, use other paper for this. I'm going to right now make a table of values. Now here's the thing. That 3, -9, that's my vertex. I want that to be in the center of my table. 3, -9. Now I'm going to pick numbers that are on each side of that 3. So I pick a 2, and I pick a 1, and I pick a 4, and I pick a 5. If we are looking for the intercepts, I do also like to get a 0 in here if I can, which means I'll probably get another number at the bottom, but we'll talk about that in a minute. So let's start with the 0. If I substitute 0 into my equation, now this is where we've talked before. If my equation looks like this, y equals x squared, I'm going to put a 0 right here. I don't even really need the parentheses, I guess. So I would have 0 squared minus 6 times 0. You could very carefully type that into your calculator exactly as is. Just hit enter and then go back in and change the 0 to a 1, and then change it to a 2, and then change it to a 3. Saves a lot of time as we're graphing and making these kind of table of values. I'm also going to say you should be able to use your order of operations in your head. 0 squared is 0, 6 times 0 is 0, that's just going to be 0. When I put in a 1, again, what's really going to happen on your calculator, you could just change this to a 1, and change this to a 1. I know that's going to look kind of messy if I do that on the board, so I'm going to rewrite it each time. But 1 squared is 1, 6 times 1 is 6, and 1 minus 6 is negative 5. When I put in 2, 2 squared is 4, 6 times 2 is 12, and 4 minus 12 is negative 8. Now here's the thing. So far, my points have been decreasing. They're getting lower and lower and lower. They're going to get to my vertex, which is my turning point. That should be the lowest point that I get, and then it should turn around and come back up again. The other numbers that I'm going to find should match the ones that I have already. Please do the math. Don't just guess that you did it right the first time. Please make sure that you go through here. I'm going to do my 4 here next. I'm going to say that y equals 4 squared minus 6 times 4. 4 squared is 16. 16 minus 24 is negative 8. Notice how those two match. This next one should be a negative 5. When I put a 5 in, I'll get 5 squared, which is 25. Oh, I'm sorry, that should be a 6 times 5 right there. So I'm going to have 25 minus 30 is negative 5. And then if I would put in a 6, I'm going to get a 0. I'll have 6 squared, which is 36, minus 36. That is 0. So when we graph this, 0, 0, then I've got 1 and negative 5, 2 and negative 8, 3 and negative 9. And then it's going to come back again. And again, my alignment is a little bit off. I'm really sorry. I'll try to do my best here. Remember, these are not straight sides. It's not a V. That vertex, because it's at the bottom of my graph, that is going to be a minimum. Now, I did say in a previous video, we care more about the x-intercepts in terms of solving these. The y-intercept is what happens when the x is 0, and that's what we're going to be looking at in this assignment. Instead of looking at the x-intercepts, we're going to look at the y-intercept. So for number 2, again, I don't have a c value here. So let me move this up a little bit so I've got some more space. Start with ABC. A is negative 2, B is negative 4 because that's the number that's in front of the regular x, and C is 0. Finding the x value for the axis of symmetry and the x value for the vertex, I would have x equals the opposite of B, which is a negative 4, over, sorry about that, over 2 times the A, so 2 times the negative 2. So the opposite of negative 4 is 4. Over negative 4 is going to give me negative 1. So I know that my axis of symmetry is negative 1. I know that the x part of my vertex is negative 1. So I could have, a little off again. I can have my axis all graphed. To find the y part of my ordered pair, I'm going to substitute in the negative 1. Now here you have to be careful. I'm going to recommend that you use parentheses. So I'll have negative 2 times negative 1 squared minus 4 times negative 1. Negative 1 squared is 1, but 1 times the negative 2 is negative 2. Here I would do a keep, change. Negative 4 times negative 1 is positive 4, and negative 2 plus 4 is 2. So my vertex is going to be at negative 1, 2, which is right here. Now we're going to make our table. So here is my xy. Since negative 1, 2 is my vertex, that's going to be in the center. Negative 1, 2. Now I want some numbers that are smaller than negative 1, which would be like negative 2, negative 3. And I want some numbers that are bigger, like 0 and 1. If x is negative 3, I'm going to have that y equals negative 2 times the negative 3 squared minus 4 times the negative 3. So negative 3 squared is 9, positive 9, times negative 2 is negative 18. And negative 4 times the negative 3 is positive 12. And that's going to give me negative 6. Maybe if I alternate colors, it'll be easier to follow what's happening. If the x is negative 2, now I'm going to say negative 2 times negative 2 squared plus a negative 4. I'm just going to go right to plus a negative on here times a negative 2. So negative 2 squared is 4 times negative 2 is going to be negative 8. Negative 4 times the negative 2 is positive 8. That's going to give me 0. Now I already have my vertex. When I put in a 0, you guys know 0 is my favorite thing to substitute. I'm going to have negative 2 times 0 squared plus a negative 4 times 0. So 0 squared is 0, times anything is 0, negative 4 times 0 is 0. This is all just 0. We like that. And again, look at that. You should know what your last answer is going to be. You should also still do the work. So when I put in a 1, I'll have y equals negative 2 times 1 squared plus negative 4 times 1. 1 squared is 1 times a negative 2 is negative 2. Negative 4 times 1 is a negative 4, and negative 2 plus a negative 4 is negative 6, which is what we were hoping it would be. When I graph this, now this one's going to look a little different. Negative 3, negative 6 is going to be here. Look at where that is versus my vertex. This time it's going to be moving up to get to the vertex. So negative 2, 0, it's right there. We already have the vertex graphed. 0, 0, and then 1, negative 6. So there is my parabola. This time, that vertex is a maximum. That's the tallest that our graph is going to get. And where this crosses the y-axis is again at 0. This problem is a little different than the first two. 3 and 4 are very similar to each other. And here's why. See if you can figure out A, B, and C. So the A is the number in front of the x squared. The B is the number in front of the x, but there isn't an x. That means that B is 0 this time. And the C is the number that's all by itself with no variables, so C is 1. So this time when I find my axis of symmetry, I'm going to have that x equals the opposite of B, which is 0, over 2 times A. Okay, I really don't care what the denominator is. The opposite of 0 is 0. 0 divided by anything is going to be 0, right? I can write this out as 0 over negative 4, but that's still just going to be 0. So the axis is at 0, the x value of the vertex is 0. That means that the y-axis is actually our axis of symmetry. Now I can find my y. Negative 2 times 0 squared plus 1. So 0 squared is 0, times anything is still 0, plus 1 is 1. So my vertex is at 0, 1. Now, when I make my table, again, that vertex goes in the middle. So I would have 0, 1 right here. I would want negative 1 and negative 2, then positive 1 and positive 2. When I substitute these in, again, please use parentheses. I'll have negative 2 times negative 2 squared plus 1. Negative 2 squared is positive 4. 4 times the negative 2 is negative 8. Negative 8 plus 1 is going to be negative 7. Again, let me alternate colors maybe to make this easier to see. Negative 2 times the negative 1 squared. So negative 1 squared is 1 times negative 2 is negative 2. Negative 2 plus 1 is a negative 1. When I put in a positive 1, nothing's going to change. I'll have negative 2 times 1 squared. Well, 1 squared is 1 times 2. Negative 2 is negative 2. Negative 2 plus 1 is negative 1. This is just crunching numbers on your calculator. Negative 2 times 2 squared. So 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 plus 1 is negative 7. So I could graph this. Negative 2, negative 7. It's right there. Negative 1, negative 1. I already have my vertex. 1, negative 1, and then 2, negative 7. Okay. That vertex is, again, the very tallest that this graph gets to. That's the maximum. The y-intercept where it crosses happens to be at the origin again. Now, I'm not going to complete this one, but we will find A, B, and C together. The A is 1. I'm sorry, it's not 1, it's 2. The A is 2. The B isn't there. There isn't a regular X there. So the B is 0, and the C is going to be 4. So I want you to finish up the rest of this one. This does say it's done. It's not really done. You have to finish up 1 through 4. So we've done 1, 2, and 3. Finish number 4. Try that one out. The answer key is in Schoology, just like it always is. And then make sure you take the formative. Let me know if you need any help.